Okay, so on to problem 3. A roofer leans the top of a ladder against the top of a 6-foot wall. If the base of the ladder is 4 feet from the wall, how tall is the ladder? Okay, so now that we've read it once very quickly, let's take a closer look at what it's saying. Okay, so the roofer leans the top of a ladder against the top of a 6-foot wall. So what that means is that the very end of the ladder is touching the very top of the wall. It's not like the ladder's up like that, or the ladder's down the wall a bit. It's like this. Okay, so we know that much. And we know that the wall is 6 feet tall. Now, if the base of the ladder is 4 feet from the wall, how tall is the ladder? Okay, so the base of the ladder is 4 feet from the wall. So what that means is, down at the bottom, down here, the distance between the wall and the ladder is going to be 4 feet along the ground. So, now that we've sort of interpreted what that means, let's take a bit of time to draw the picture. Right? Since now we are working with physical pictures, physical objects, we can draw nice pictures of them. So, it's not art class, it's math class, so we don't need to be too pristine with our drawing. All I'm going to do is I'm going to draw out like that, right? Here's the wall, and here's the ladder touching at the tip, and then what you want to notice is, first off, this wall is straight up and down with the ground, so that means that there must be a 90-degree angle here. And then, so we have our ladder right here, we have the wall right here, we have the floor right here, and then it's a 90-degree angle between the floor and the ladder. I'm sorry, the floor and the wall, as it is straight up and down. So what's useful about this? Well, we see right here that we have a triangle. Now, let me tell you why this is useful. If we have a triangle, right, and we know this is 6 feet and this is 4 feet, right, we can easily find, if we know two sides of a triangle, we can find the third side. So, based on what they said here, the wall is 6 feet tall, and the distance between the base of the ladder and the base of the wall is going to be 4 feet. So, now, hopefully you remember this formula right here. A squared plus b squared equals c squared. Right? Pythagorean theorem. The way this works is a and b are the two smaller sides of your triangle. It doesn't matter which one's a and which one's b, but these are a and b right here. And then c is the length of what we call the hypotenuse, which is the long end of the triangle. So, if we know any two of these three quantities, we can find the third through this equation. In this case, we know this one and that one. We'll just plug in here, right? Let's say that 4 is A, 6 is B. Again, it doesn't matter. We'll end up with c squared equals 4 squared plus 6 squared. Now, 4 squared is going to be 16. 6 squared is going to be 36. And then we add these two quantities together. That's going to be 52. So we know c squared is 52. But what we want is just c. So what we're going to do is we're going to take the square root of both sides. So now at this point, square root of c, we're going to want to simplify that a little bit. We see that 52 is just 4 times 13. Square root of 4 is just going to be a 2. So let's pull out a 2, root 13, like that. And then this here is the exact answer. So 2 root 13 feet. Now, that's not too, in real life, you don't normally use like square roots to describe how long something is. So what you do is you do 2 times the square root of 13 in your calculator, and you would get 7.21 feet. And then that right there is the length of this side of the triangle, which is also the length of the ladder. So this is why it's so important to draw pictures if you're talking about a physical object, is because you probably wouldn't think to treat a ladder leaning up against a wall as a triangle unless you drew the picture. But now that we did draw the picture, it becomes quite clear that that's exactly what we need to do. Now on to the fourth and final example problem.